Your heart works every second of every day. Shouldn't your supplements work just as hard? Introducing 3 powerhouse cardio support products from Protocol for Life Balance. Nattokinase, drawn from a centuries-old Japanese tradition. This remarkable enzyme helps maintain healthy blood flow and normal blood fluidity. Circulation you can count on naturally. Next, ubiquinol. This is the active form of CoQ10 your body actually uses, fueling cellular energy production, neutralizing harmful free radicals, and delivering superior absorption. And finally, Clinical Cardio 6. 6 powerful nutrients, 1 capsule, including L-carnitine to energize your heart, hawthorn, and Mega Natural BP grapeseed extract for healthy blood pressure, and MK7 to keep your arteries flexible. Comprehensive cardiovascular support, all in one. Protocol for Life Balance, science-based professional-grade products using ingredients backed by strong research. To order, go to drhoffman.com/protocol for life balance. That's drhoffman.com/protocol for life balance. Protocol for Life Balance is an A-rated GMP manufacturer of premium dietary supplements. Welcome back to today's Intelligent Medicine Podcast. I'm your host, Dr. Ronald Hoffman, and our guest is co-founder of Geniro, which is a California-based biotech company. He's written a great book entitled On the Future of Species Authoring Life by Means of Artificial Biological Intelligence. So you're an expert on genetics. In fact, you've written a book entitled An Intelligent Person's Guide to Genetics. And so explain to me, like I'm a sixth grader, the difference between germline versus somatic gene modification. Okay, because
that's an easy one, right?
Okay, so good.
Somatic modification is basically changing the genes in any cell in your body except an egg or a sperm, right? So if you somatically modify a genome, the changes will not be inherited, right? That's absolutely critical. But if you modify the DNA in the germ cells, that's egg or sperm, then those modifications will be inherited by your children, right? And I should make it clear that I am firmly against any form of germline modification.
That appears to be where there's kind of a red line in genetic research.
Yes.
And actually, there was a Chinese scientist in a celebrated case who got in trouble because he created an HIV-proof human, supposedly.
Yeah.
Tell us about that story.
Well, yeah, I mean, I won't go into the details of that, but it turns out that the whole logic of I mean, there was some science, behind what he was thinking, but in fact, it was the whole way he did the experiments and so on and so forth were totally flawed, and ethically, there was some really serious issues with what he did, and lack of proper informed consent and so on and so forth.
Didn't tell the people what it entailed, right?
Well, there are many reasons why what he did was just totally wrong, right? But if we just move on from that, it becomes a kind of broader, again, philosophical issue, which is that we are nowhere near ready, in my view, to start to contemplate introducing changes into humans that are inherited. And there are many reasons for that. There are safety reasons, because as of today, we still are unable to make really precise changes in a way that don't sometimes go off target, right? And
there
run
could be
the
like
risk
knockoff effects.
Yeah, like what we do is more like a shotgun than a rifle, right? Mm-hmm. There's off target which you don't always aren't always able to detect sensitively enough, right? But even if you could, and there's some technologies now that claim to be far more accurate, right? There are broader issues, philosophical issues and ethical issues about, tampering with the genomes of unborn people, right? And I think it's kind of a huge qualitatively different step to start fiddling around with inherited changes. And, I don't doubt that one day we will, right? And you could argue, well, if you could just fix,
in other words, eradicate diseases from the human species, or medical.
If you could just look, you could argue we eradicated smallpox, right? Smallpox was a virus, right? It's not part of humans, but hey, we had a global program to eradicate smallpox. We had a global program to eradicate polio, right? I mean, polio used to ravage, you know, every summer there were like, thousands of kids in the US would die of polio or become permanently paralyzed, right? Mothers were terrified to let their kids go outside, and then Salk and others produced a polio vaccine and pretty much eradicated polio. And we don't think about it today, right? But um, but of course, the eradication of a virus is slightly different because you're not actually, you're
It's
eradicating the virus.
extrinsic to
Yeah, it's
us.
extrinsic. But I mean, and you could argue, and it's not an unreasonable argument that there are, 7,000 odd diseases which you have kind of faulty genes, so to speak, which behave like a broken clutch in a car. And what do you do when you break a clutch? You put in a new one, or when your brake pads wears out, you replace the brake pad. When you get a punctured tire, you put on a spare tire, or replace it. And there are about 7,000 diseases which appear to behave in that kind of component-like manner, and that if you fix the broken component, the broken gene, you get rid of the disease, right? But even
But
in those
for example,
cases,
in sickle cell, it seems to be there one gene locus. But when we're talking
yes.
about a big killer like hypertension, for example, to
Well, I
cure
was going to say
hypertension,
that
there's so many
the
different genes.
most diseases, the majority of diseases are so-called polygenic, which means there's more than one gene involved, and it can be anywhere from two to hundreds or even thousands, right? Each making a tiny contribution. Height is a trait, which is a really good example of that. We know that the huge numbers of genes that contribute to height, right? And the environment does, and so on and so forth, right? But most diseases, like you say, are polygenic. They're so-called complex diseases, and there's no way on earth using the current paradigm, anyhow, that we'll be able to address those. But even if we just think about the simple monogenic diseases caused by a single genetic abnormality, I still don't think we're ready to start trying to fix those forever by changing
Mhm.
people's germline. Having said that, I imagine that there may come a point where somebody else would argue, well, look, you know, to cure, I mean, let's take sickle cell disease, by the way, is a horrible,
Yeah,
horrible disease, right? Hugely underfunded, and that's a very interesting issue. We've put huge amounts of money into diseases like cystic fibrosis, which kind of affect a handful of people. But sickle cell is affects huge numbers of people in the US and all over the world, and has had very little funding. Right now, recently, there have been two very successful gene editing or gene replacement based methods for actually curing sickle cell disease. But guess what? They cost $2 to $3 million,
right.
depending which one
Do
you
you think it'd be
subscribe to.
possible to scale it? Because it just,
Well, look, I mean, if you think if Pakistan or India or Africa, somewhere like Nigeria, where huge percentage of the population, or Congo, have sickle cell disease, right? If they were to kind of treat everybody at $3 million a go, they'd consume their whole GDP
yeah.
on treating sickle cell disease, right? Which clearly isn't feasible, right? So I can imagine a time may come, and remember, with sickle cell disease, it's a horrible disease. A lot of kids die by the age of 5. It has, they have these terrible pain crises. They get strokes,
Yeah, they're
heart
all addicted
attacks.
to opiate
It's,
pain medication.
it's just that you get addicted to pain medication. They get depression. It affects their families. Their lives are a mess. It's just a horrible, horrible disease, right? But if you really wanted to treat everybody, the only way you could ever probably do it in an affordable manner without having to retreat every generation would be probably at the germ level, so that you just get rid of the gene,
Yeah,
right? But
eradicated.
but then
Yeah.
guess what? Then suddenly there's a resurgence of malaria and you
Yeah,
wipe out half
exactly.
of Nigeria,
Yeah,
right?
if
So,
civilization breaks down and the mosquitoes come
yeah.
back with malaria, then
Well,
you're in
and
trouble.
with global warming, it's actually happening. It's getting so what I'm saying is that the funny thing about life and evolution is that it's always kind of one step ahead of us, right? We think we're being clever when we do something, and then we find we've just created an Achilles heel. But I just don't think civilization, society is ready to contemplate making permanent changes to our genomes, even at single gene level for single disease. So, you were talking earlier about changing human nature. I mean, you can see how far away that is from what I'm talking about when even I am resisting
Yeah.
treating diseases at the genetic level, which
What
the
about
change
the
is permanent.
what about the potential for these technologies to be harnessed by bad actors, by authoritarian regimes?
Yeah,
Because
well,
there's
that
some
that
countries
that
that just don't have the ethical
Well, well,
boundaries
well,
that we
well,
have.
well, the two things here, yeah, and the two things here, one is obviously that, authoritarian societies may insist that people are, well, they may only create new humans through some form of, genetic technology, in which
Create
case,
super
eventually,
soldiers, for example.
yeah, look, we're not there yet. At the moment, we can't reverse engineer human nature, but there will come a time in the future when we'll have a pretty good idea of, the genetic basis of a lot of aspects of human nature. That's not to say that everything's genetically determined, which it clearly isn't, right? There are many layers of information that make us what we are. But at the end of the day, genomes, genes set the kind of scene, if you like, right? They're the kind of basic substrate. Look, the same genomes, more or less, created the kind of horrific culture of the Incas who used to sacrifice humans, and
Tear
they
their
created
hearts out of their bodies.
and
Yeah.
they created Christianity as well, right? So these two extreme cultures can be created from more or less the same genetics, right? And again, that's why human nature is so fascinating, is that the same genome can accommodate these diametrically different ways of existing, right? And that's the remarkable thing about human nature. So I don't think, you'll ever be able to create manipulate the genome in a way that doesn't allow you to become an Inca, and human, and doesn't allow you to behave in deplorable ways or whatever,
Without some off-target effect that might impair human capabilities
yeah,
that are
and as I
positive.
said, and neither would we really want to. Having said that, there will always be people who will try and do that, right? So that's one dangerous thing in the future, right? Nearer to home is using this technology as a form of biological warfare, either nation states, terrorists, or individual bad actors, unstable individuals, or for political reasons or whatever reasons people have to do bad things. That is a serious danger, and I don't think we've got really enough time to kind of really go into that
You
debate,
mean
other
like
than to say
genetically
it,
modified viruses and plagues?
yeah,
That,
yeah,
yeah.
yeah. And that's a real issue, and there are ways to deal with that. And things like bioradar, where we kind of monitor the environment, and we involve ways of rapidly creating vaccines and things like that, right? And screening DNA that's made, right?
Okay, folks, at this point, let's pause and allow one of our sponsors an opportunity to share an important message with you. So here it goes. Listen up. Your heart works every second of every day. Shouldn't your supplements work just as hard? Introducing 3 powerhouse cardio support products from Protocol for Life Balance. Nattokinase, drawn from a centuries-old Japanese tradition. This remarkable enzyme helps maintain healthy blood flow and normal blood fluidity. Circulation you can count on naturally. Next, ubiquinol. This is the active form of CoQ10 your body actually uses, fueling cellular energy production, neutralizing harmful free radicals, and delivering superior absorption. And finally, Clinical Cardio 6. 6 powerful nutrients, 1 capsule, including L-carnitine to energize your heart, hawthorn, and Mega Natural BP grapeseed extract for healthy blood pressure, and MK7 to keep your arteries flexible. Comprehensive cardiovascular support, all in one. Protocol for Life Balance, science-based professional-grade products using ingredients backed by strong research. To order, go to drhoffman.com/protocol for life balance. That's drhoffman.com/protocol for life balance. Protocol for Life Balance is an A-rated GMP manufacturer of premium dietary supplements.
Kids don't just bring home homework, they bring home germs. And those germs don't just stay with them, they spread to the whole household. That's why Clear Nasal Spray was created by a practicing physician to give parents and grandparents peace of mind. You may not think about it, but your nose is filtering out a semi-truck full of air every single day. Clear isn't just another spray. It creates an additional layer of protection in your nose that blocks bacteria and viruses before they can even take hold. Yes, even that virus. Supporting your body's defenses right where germs first try to enter. Clear is a hygiene product recommended for daily use, drug-free, non-drowsy, and safe for all ages. Just a quick spray in the morning and evening helps you cleanse your nose. Don't just hope for protection, create it. Get Clear Nasal Spray, your daily defense. Clear Nasal Spray is available at retailers nationwide and online. Check out Xlear.com for our special offers. That's Xlear.com.
Thanks for listening. Thanks for supporting our sponsors. They are what make intelligent medicine a continuing free experience for you. And now back to today's guest, Dr. Adrian Wolfson.
We've talked about healthcare. We've talked about the kind of more fanciful ideas of whether people ever try and change human nature. We've talked about disease, longevity. We've talked about biowarfare and the people who might try and change human nature in authoritarian societies. But let's now try and focus on the good things about this technology, right? Because I think this technology has tremendous benefits that it can bring to humankind. And obviously that's why I find it so compelling and fascinating. And this is now beyond what it can do for healthcare, right? And some of the things that it can address, bioenergy, agriculture, bioinformation storage, biocomputing, biomaterials, and so on, right? So, for example, spider silk is something that we can make spider silk has the same tensile strength as steel, right? And we could use AI to redesign the gene for spider silk to make it 10 times, for example, the tensile strength is steel.
In other words, biological materials that exceed the capacity of our physical materials.
Mangrove swamps can desalinate water. So what if we could use biology to create clean water for the developing world, right? What if, 10% of the world's energy is used to archive digital information. You and me and most of your listeners will have huge numbers of photographs on their phone that I promise you none of you will ever look at. You have huge numbers of emails and documents on your computer, which I promise you will never look at. But will you ever delete them? No, because we all have this kind of feeling that
Thanks for letting me off the hook, because I've been feeling guilty about that.
We might just want to pull up that email or pull up that photograph or that doc, right? Now, the bad news is that it takes 10% of the world's energy production to keep all of that stuff on your phone and your computer and anywhere else you might store it, right? But what if, for example, you could store that information in DNA, right? Now, DNA is a very information-rich material. It's a digital material, so it naturally accommodates digital information. And it turns out that you could store the entire Earth's digital information in a pretty small amount of DNA, right? So it's one of the things that we're working on. The technology we've developed is particularly well suited
so
to doing
not
that.
to create life forms or to create cures for disease, but to create a matrix for information storage and retrieval.
That's right. Yeah. And I believe that, in another 10, 15 years, when you're watching your movie on your cell phone, that might be, a movie that's stored in DNA, and you'll read it in real time, and you'll be storing your information in DNA. Your computer may be computing using biological components. Your clothes might be made from, biological material. Your house, you might grow your house rather than build your house. Your cell phone may be living. Your clothes may have embedded intelligence. Your crops may have been grown in the Sahara Desert, because we can engineer and rewrite the genomes of crops to grow in the desert or in high saline environments, or in extreme cold, or in areas where there's very little light, right? So what I'm trying to say is that pretty much all of the infrastructure around us could benefit from using biology, and biology is a sustainable material. So, one of the key messages of my book actually is that in working with synthetic biology and artificial biology and generative biology, and turning biology into a programmable material, actually what that can help us to do is to preserve the natural world as we know it, prevent us from mowing down rainforests. In 2060, we're going to have more than 10 billion people on planet Earth. We had our first green revolution, but we haven't had the second one. Food production right now is just not fast enough or efficient enough. We need to go way beyond what we're doing today. If we don't, we're going to be mowing down every remaining tree like they did on Easter Island, right? If you know that story, right? And we're going to be
Right.
losing all the
Humans have devastated their environments from time immemorial.
That's right. We're going to be mowing down all the last wildernesses and all the species that inhabit them, right? And we're going to degrade planet Earth, like, and we're going to trash it permanently, and we're going to destroy it for the future generations. We cannot allow that to happen. And I believe that biology is the way out of that, right? The technologies we're developing to design life and to build life will enable us to save life, right? So, everybody who's scared about this technology, just think about the good sides and think that there are responsible people too, like myself, who think very carefully about what the guardrails need to look like, right? There are always going to be crazy people out there who don't respect guardrails, but that didn't stop us from using fire or the wheel or electricity or any of the other countless technologies that, or steel, that has a dual use. What Carnegie did with steel was create industrialized America, which had geopolitical consequences, enabled railways to be built, bridges to be built, skyscrapers to be built. It also enabled warfare, right? Because steel, became a very important component of warfare. But, every
The
technology
unintended consequences.
has other consequences. But what we can't do is stop inventing, and deploying technologies that help us to live better lives, right? So that's not the solution. The solution is to make people aware of new technologies, as I've done with my book, in a way that's kind of entertaining and accessible, and hopefully engaging. And then people can help advocate for ways in which, these technologies can be used responsibly and safely and wisely and ethically in a manner that benefits society. But we first need to be aware of them, and we need to understand them, and be conversant in them before we can get to that point. So, I feel that with my book, I've caught the moment before anybody else has done, and I've kind of got the message out there. I saw it happening in real time, and I was the first person to write about it, and I hope that my book will be important in helping people to navigate this new world. I see my book as like a kind of guidebook. When you go to France or Italy, you generally would buy a guidebook. I mean, these days you look on the internet, but in the old days,
Yeah, we have no guidebook for what's coming down the pike. I think
that's
your
right.
book attempts
But
to
I
address
see
that.
I see my book as a kind of guide, but it tells you, which restaurants to go to and which routes to take, and the tipping customs, and which are the mountains that you must climb, the ones to avoid. And so my book's like a kind of guidebook to the future of life, right? This is where we should go, this is where we shouldn't go, this is how this technology could be useful, this is how it could be dangerous. These are the, pitfalls, these are the positive aspects. This is how I see my book. It's a guidebook to the future of life.
Great stuff. Yeah, and that's why I enjoyed reading your book, because it has a really balanced approach. On the one hand, you talk about these amazing developments that are coming down the pike, but you also issue certain cautions, and you certainly uphold the need for guidelines, restraints, applying ethics, and applying a
Yeah.
better understanding of history.
And I've generally had good reviews, but there've been one or two people who've given me a good review, and then they say, "Oh, but then in his manifesto for life," because I've written the first ever manifesto for life, which is the last chapter of my book. They say, "Oh," and then he talks about things like, kumbaya, everybody holds hands, and they create governments to the global scale, all these things, but he doesn't really provide the answer. Well, I can't do everything, right? I mean, all I can do. I mean, I'm a scientist at the end of the day. It's not necessarily my job to find the perfect way for the world to align and sort this out. But, beyond what I say in the book, I honestly don't know what else I could say. I pretty much wrote down everything I could think of. And you know what? If you can think of something better than me, whoever you are, then please
Well,
go
it,
ahead
it
and
could
do
ignite
it.
a conversation, a debate about,
Yeah,
where to
yeah.
go. And I think that's
I'm
important.
not. I'm not claiming I've given the definitive, view on everything. And how could I, right? And in fact, I say in my book, I see my book as being a sketch for a manifesto that other people can fill in and improve on.
Here's an idea. Please send a copy of your book to every member of the U.S. Congress, okay, the House of Representatives and the Senate, because these are the
Ah,
people who are going to be creating guardrails around some of
yeah,
the technology that's going to be
maybe I
rampantly
should
developing.
actually.
I, that's,
Maybe I should. Maybe I should do that.
I think that would
Yeah.
be a good idea. All right. Thank you so much, Dr. Aidan Wolfson, for joining us. And more information about your company that you co-founded, Jenny Rowe. Can people get information about
Yeah,
that?
just very briefly on that one. Yeah, Genero was founded by myself, Brian He at the Arc Institute in Stanford, who's a brilliant genome designer. He's built some of the most advanced AI in the world through interrogating these huge databases of genomes from many different species and trying to kind of pull out grammatical principles. And that enabled him to design the first ever computer generated biological entity, which to me was the kind of Wrights brothers moment of biology when we kind of took off and bumped to the back to the ground, but we took off and we realized that there is this huge future out there. My other co-founder is Kai-Hang Wang, who's a professor at Caltech, and he's invented this incredible technology called Sidewinder for building genomes, which we licensed.
Wow.
And then the fourth co-founder is a guy called Noah Robinson, who's the brilliant postdoctoral student that did most of the work in Kai-Hang's lab. So, we built this company. We've got it funded through venture capital and some high net worth oil kind of magnates and people who've done well in Silicon Valley. And we're building out the technology to do this and focusing on some areas of civilizational importance, like DNA information storage, for example.
Good stuff. All right. Well, thanks very much for joining us. Appreciate your work. All the best to you. And I think the book on the future of species, authoring life by means of artificial biological intelligence, is a great primer and introduction to, and I think also is kind of looking into the crystal ball about what's coming down the pike in terms of biotechnology. So thanks for writing it.
I kind of wrote it in a way that should be timeless, deliberately, so that it remains relevant, kind of indefinitely. But Ronald, it was a great pleasure being on your show. Thank you so much for having me on.
My great pleasure. Dr. Ronald Hoffman here, and this is Intelligent Medicine. I want to thank you for listening to the Intelligent Medicine Podcast. Follow us on Apple Podcasts, Spotify, Amazon Music, or your favorite podcast app, and get new episodes automatically downloaded every weekday. And please give us a rating and review. It truly helps new people discover intelligent medicine. The Intelligent Medicine Podcast is for general informational purposes only and does not constitute the practice of medicine, nursing, or other professional healthcare services, including the giving of medical advice, and no doctor-patient relationship is formed. The use of information on this podcast or materials linked from this podcast is at the user's own risk. The content of this podcast is not intended to be a substitute for professional medical advice, diagnosis, or treatment. Users should not disregard or delay in obtaining medical advice for any medical condition they may have and should seek the assistance of their healthcare professionals for any such conditions. Finally, please visit drhoffman.com and discover everything Intelligent Medicine has to offer, including frequently updated, unbiased health news and fully vetted product and supplement recommendations. You're listening to Intelligent Medicine, a resource to help you take control of your health. We offer a balanced, objective analysis of all your health, wellness, and aging options, both conventional and alternative. Now you can take your engagement to the next level by joining FullScript. FullScript is my online dispensing platform that only offers curated, professional-grade supplement brands that I know and trust. Never counterfeit or expired, always stored and shipped correctly. Just go to drhoffmanstore.com for more information and to start your free FullScript account. Buying through FullScript offers fast, free shipping, optional refill reminders, a mobile-friendly site. It's safe, secure, and HIPAA compliant and offers world-class support. Just go to drhoffmanstore.com. You'll get access to the supplements and features you need to help you achieve your wellness goals, including my custom targeted protocols that combine the products I recommend to address specific needs, heart health, immune support, and much more. It's all at drhoffmanstore.com. drhoffmanstore.com.